Okay, so this session covers a fairly difficult topic called data structures. But before we do, let's have a quick look at some of the data types we've seen so far. You can have integers, which are whole numbers, floating points, or single precision floating points to be more precise, double precision numbers, which we've not really used that much, but they're the alternative to single precision floating points. You can also have individual characters, which incidentally, let's give them some default values. So integers could be like a whole number, a floating point number. You could put 50.0, but that would be a double. So you have to put f on the end to turn it into a floating point. Characters are individual letters or punctuation marks or symbols, but they're put inside apostrophes to make it marked as a single character. And booleans, which can be either true or false. We've also seen one type though that is a kind of a data structure already, and that's a string. To assign a string a value, you don't put it in single quotation marks, but double quotes, like so. And that makes it a data structure because it's got more than just one individual character. There's the character H, E, L, L, and O, and they're strung together, hence the name string, into a string of text. So the difference between them is, apart from the fact that it stores more data, these types are, some people call them atomic types because you can't split them like the atom. But really what that means is these are value types. When you declare an integer, a floating point, a character, it sets aside an area of memory to store that one individual value. But when you declare a structure, like a string, what it does is it actually allocates a place in memory to store another memory location, a reference to where the rest of it is kept. And it points to the first character in this case. Now you don't see any of that. That all happens behind the scenes. But when you create a string, what it's actually creating is a memory reference, and then in that area of memory that is referenced, it starts storing data. So it starts with that character, and it just continues on, in this case, until it reaches an empty or null character at the end of it, and that's how it works underneath the hood. But the key there is it's storing a reference. The rest of them are actually storing a value. So these are value types, and this is a reference type. String's a little bit special because it's built in some ways it works almost like a value, but it is definitely a reference type, ultimately. So with that in mind, let's take a look at our first data structure, and it's a struct. So a struct just combines different pieces of data together into one. And a struct turns blue, it's a keyword, but when you start typing the identifier, that whatever you want to call it after, I called it player, it could be anything you like, but we chose a name there for our structure, and it turns cyan, and that cyan color is the default color used for structures, classes, enums, all these kind of things that are used to define other objects. So let's make every player have a string for a name and an integer holding that player's score. Now, that would normally set aside space to store these two things, but it's inside a structure, and a structure itself is a value type. But we haven't actually created any values, so this on its own does not set aside any memory. But when you then use that class to create an object, let's make a player called P1, that is now creating an area of memory for storing these two things. Now underneath the hood, what it's really storing is an integer and a reference to where you'll find the rest of the name. But let's not get into the too messy details just yet. So the player has these two objects in it, the name and the score. So we try and say player1.name equals Dave. We get two error messages. The first one's going to go away in a minute, use of unassigned local variable. It is unassigned, but because it's a value type, that doesn't really matter. If it's a value type, the data is right there, so it has to have something. And that will all be 0 initially, but it's definitely there. What it's really complaining about is that the name is inaccessible due to its protection level. Now, by default, everything is assumed to be private. So we don't have to put this in. If we don't put it in, it will be implied. But the alternative, as you may have guessed, is to make it public. Now, public objects, being the opposite of private, they can be accessed anywhere. If something is private, then it exists only within the curly brackets. It's sort of like a local variable. These are called member variables. They are members of the player structure. We've seen member variables already for the program class. We'll get back to classes soon, promise. But for the moment, these are no longer private, they're no longer local to this area. They can be accessed from some other set of curly brackets elsewhere. But to do that, we have to have an object, in this case, P1. So P1 can be given a name, it can be given a score, and we can do things with it, like we can make it display the score onto the screen. So player's name has, just concatenate all this together, and then put the actual score value in, and end it with the word points. Don't forget a read key, otherwise it will just pop up and then disappear. So if I run that, it should say Dave has 100 points, right? It does. Excellent. So that's called instantiating. We've created an instance of the player structure, and that instance has been given the identifier P1. All right, so, and we've also put in these, they're called accessibility modifiers or protection level. So there's private, there's public, there's also one called protected, but I think that's probably for another time. So it's very often the case that you need to make things public before you can access them. This is not necessarily the best way to do things. You can use properties and stuff like that, but again, that's a more advanced topic for another time. So what happens though if we do this? We don't assign it a name and a score. Suddenly it turns red. Use of possibly unassigned field called name, and the same thing for the score. Because it's a value type, the values of this data is directly stored, and it recognizes that it hasn't actually been initialized. Now, if I was to declare that as a member variable, it probably would make that error go away. Am I right? Let's. Oh no, it's still saying it's still smart enough to realize that. Oh, sorry, it's because it's not static. Okay, all right. Now it's still not initialized, but because it's outside of the immediate local scope of that command, it doesn't know that it's not been initialized. So we've kind of got away with it. It's going to end up null, and you should really avoid doing that, but it's not smart enough to tell you that you should avoid doing that. But if you declare it locally, it knows that it hasn't been given these values, and it won't let you access them because it hasn't been given those values. But initialize them, and it's fine. So just like other value types, it should be initialized before you make use of it. We could alternatively use a thing called a constructor. So it's not initialized, but we can say equals new player instead. I think you have seen the new command. Oh, it's fully qualified that reference for us. I don't think that's strictly necessary. I think we can get rid of this bit here. I'm not sure exactly why it did that. Probably because the structure is inside the program. We could have defined that up here, and it would work just as well. That's probably more of a conventional way to do things anyway. Okay, so now what it's done is it's ran a constructor method to create a player object for us, and that has initialized it for us. Where's this constructor? It doesn't exist. Well, again, it's implied. There's a default constructor which it makes for you, and that more or less just looks like this. I think that may be all we need. Or it's not. You can't put parameterless. I forgot about that. We'll see them actually for classes. It's not so simple for structures, but effectively it does do that. It does run a piece of code which just initializes these variables to their default values. And if we run that, what is the default value for a name and a score? You can probably guess. The string will be empty and the score will be 0. So what if we do make it a class? A class looks exactly like a structure, and in many ways it does act the same. In fact, if I run it right now, it does exactly the same thing. What the main difference I'm going to tell you about right now is that a class is not a value type. It is a reference type. I don't think I mentioned, by the way, that the value types can be stored in a memory called the stack, which is much quicker to access. So integers, booleans, floating points, structures, they're much quicker to get at whereas things that are references, because of the way they're accessed, they have to be stored in another bit of memory called the heap, which is considerably slower. Now, not everything that can be stored on a stack actually is, but potentially value types are faster. Classes, however, are reference types. So because of that, apart from it having to be on the heap, you can assign initial values, which you couldn't do with structures. So we could give the player a default name. You could give them a default score. And you can create a default constructor. So a constructor, if you were to make your own, it would look like this. We just have public. Almost all constructors are public, followed by the name of the object you're creating. Now, why don't I have to put in void there? Well, the reason is because it's not void. It's not returning nothing. It's returning a player. And you can set default values in there instead, if you wish. And as long as you run the new player method, it will run this code and set up the class for you. Let me just make sure that all runs correctly. We should see that Steve has 100 points. Yep, there we go. So what if we forget to say new player now? Now with the previous structure, that would be fine, but now it's saying P1 use of unassigned local variable again. We got away with that before because it was a value type and the data was stored directly there, but this is a reference type, and if you don't have a reference to anything, then it's basically null. If I run it right now, if I press F11, step through, oh, I'll have to comment out that line before it let me do that. Step through, P1, null, there we go. So that's why it won't let me use it. If it did let me try to use it, it knows that that would be null and it wouldn't work. It would crash, so it doesn't even let it compile for me. So you can't use classes until you instantiate it by using the constructor. So that's creating an instance of the player class called P1. Don't confuse the class and the instance. That's an object that physically exists in memory, whereas the class doesn't physically exist. It's more of a sort of template telling you how to create objects and what they can do. Okay, now what else can we do? Let's say we make, instead of P1 being local, we make it a member variable of the program. Now because it's being declared non-locally, it's in a different scope, it's in the whole program scope, it's a member variable, instead of being local scope to the local to the main function. It doesn't recognize that now that P1 is null, and it's not, it can't warn you basically that that's going to be an error, but when you run it, it will be an error. You get the yellow debug line because it's popped into debug mode due to an exception, a null reference exception. We're trying to refer to this P1 object, which is empty, it's null. So you can't access parts of it, as there's no parts of something which is null. If it doesn't exist, you can't get its name. So that's that error message. You can actually instantiate it as part of the declaration, even though it's static. That will run that as the first thing it does. Statics are always the first things it does. Okay, so that's the two basic data types, a structure and a class. And these are what we call heterogeneous. You can put different data types inside a class or a structure. This one's got a string and an integer. But if you want to access multiple objects that are the same, let's say we wanted to have a high score table. You could create a high score class. It becomes a bit unwieldy fairly quickly once you've got a decent number of high scores. If there was 10 of those, I mean, it would work, but that's pretty inefficient, prone to error, and just needlessly difficult. What you can do is use something called an array. I mean, that's just 10 scores. Imagine if there was 100 or 1,000 of something. You definitely wouldn't want to sit and code that many different copies of the same the same code. So that's what arrays are for. So let's try doing that or something like that as an array. Let's say some cards. So we could have an integer for a single card. Let's say give it a value from 2 to 10. We'll forget about the face cards for the moment. So each card has a value from 2 to 10. Now, if you want to have more than one card, you indicate that it's an array by using square brackets. And at first, those go there. So just empty square brackets after the data type in the declaration tells us that it's going to be an array of cards. And it will store, sorry, an array of integers called card, or cards, let's call it cards, plural. So how many? We don't know yet. So it's going to, but we do know that it's going to store a bunch of numbers. It's the same type of numbers. They're all 32-bit integers. But it hasn't been initialized. So there's different ways you can initialize something. We could say cards equals new again. There's new again. So new integer. But this time we say how many? 5. You do not say that here. It won't like that. Come on, pop up. There we go. Red error message. Array size cannot be specified in a declaration. Instead, you have to do it in the new function. Why doesn't it like this? Name cards does not exist in the current. Oh, I'm an idiot. I've not put it inside a function. Sorry. So there's our main function. It declares some cards and then it initializes it. It says there's going to be space for 5 of them. If I step through it, cards is currently null, but if I run the next line, cards then has 5. It's an array of 5 things, and you can open up the elements with that little arrow. There's 5 of them. They all take the default value of an integer, which is 0. And after that, you can then assign individual values to each one. So we put in what's called an index. And inside the square brackets, we say we're going to access object number 0. I'm going to deal card 5, for instance. Object 1, we're going to deal another different card, card 8. And then a 3, and so on. Now, how many is there? Well, there's 5 cards. 1, 2, 3, 4. So this is going to be our 5th one. And it's number 4, so it's always off by 1. They say here's more programmer humor for you, if you can call it that. They say there's the 2 most common types of error in programming are typos, missing brackets, and being off by 1. And the most common cause of being off by 1 is the fact that arrays start from 0. So if there's 5 of them, they'll be numbered 0 to 4. And you can assign individual values to them, 1 by 1. And sometimes you do have to do it that way for various reasons. Maybe there's different data, or you're generating the data procedurally, or getting it from the keyboard, whatever the reason is. If I go through all that, we've got 5 values in an array. If you know in advance what all the data is going to be, there is a shortcut you can take. You can just put them inside curly brackets, and let's deal just a bunch of cards like that. There's our 5 cards. And that's basically a shortcut for the exact same code. You can make it even shorter still. If you can leave out the 5, because what it will do there is it'll count these and say, oh, there's 5 of them, and it'll make it an array of 5. It also knows it's an integer, so you can even leave out the word int. And in fact, it knows we're initializing it, so we can just shorten it to that. That is valid. It's valid if you do it at the exact same time as you're declaring it, beg your pardon. So that is the shortest way to initialize or populate an array with data. But any one of those approaches is perfectly valid, and some of them will be required depending on whatever situation you might be using the array for. But these, as I say, are accessed individually using indexes. These are the array elements. And another way you could initialize them is in a loop, which is why we covered loops first. Loops and arrays go together like hand in glove. So let's say there's going to be 5 of them. We could use a for loop starting from 0 until we reach 5, going up by 1 each time. And what we'll do is we'll access each card individually. So instead of accessing card 0, then 1, then 2, then 3, then 4, we have this variable called I, which is the loop iterator. And that's going to go from 0, and it's going to stop at 5. So it will go 0, 1, 2, 3, 4. and when it hits 5, it's not going to go through the loop again. So I will take on the value of 0, 1, 2, 3, and 4 one at a time. I'll go through that in a sec. And you know, if you're dealing cards, it would be random. Let's not make it random for now though, because I want to make it quick. We'll do some kind of programmatic calculation. Each card is going to be numbered according to where it is in the deck. So step through, assign 5 cards. Here we are, 5 of them, all 0. When we start the loop, I is 0. 0 is less than 5, so card I is 0. Card 0 is going to be equal to this calculation here. It comes out to 2. Card 0 has the value 2. Then I goes up. I is no longer 0, I is now 1. But 1 is still less than 5. There, 1 is less than 5. So it goes in here and assigns a value to card 1. And now we've got 2 cards dealt. Then I goes up from 1 to 2. 2 is less than 5. Assign card number 2. Goes up to 3. Assign card number 3. Goes up to 4. Assign card number 4. When it reaches 5, 5 is no longer less than 5. So it quits the loop. And now we have dealt all our cards programmatically. Which is a word that I didn't think was a word, but there you go. Right, so that's using a loop to initialize an array. Now there's a principle in programming called DRY, or DRY. It stands for don't repeat yourself. And we have repeated ourselves. We've put the number 5 in here twice, and that's kind of a magic number. It's good to get rid of those if you can. So I'm going to create a constant variable. Sorry, constant variable. What am I on? A constant piece of data, which is an integer, and it's going to tell us the number of cards we have. So if that's set to 5, and what we can do is every time you see the word the number 5, we can put number of cards in instead. And that will eliminate one of the magic numbers. It means that if you ever need to change the number of cards that are being dealt, we just change it in one place, not 2. Which may not sound like a big deal, but if you imagine a much bigger chunk of code where that number 5 appears a lot, it could mean a lot less refactoring. But there's also some built-in methods that you have in arrays themselves. So what we could do, instead of saying number of cards, we could take the cards array and hit the dot operator. It tells all the things you can do with arrays. There's quite a lot. But the one we're after is called length. Get the length property of the array. Now, if that's 5 objects in it, then cards.length is going to be 5, which is what we had in there earlier. And if we ever change that to 10, then cards.length will be 10, and it will immediately modify that loop. So that saves a lot of time in restructuring as well, refactoring, sorry. Okay, so it's probably time then to make a basic game using arrays. And a lot of these use randomness, so let's put in a random number generator. Whoop, I can't type today. We'll have 5 cards, a for loop going from 0 to the length of the array. But this time we'll use RNG, so it's going to be a random number from 1 to 14. This does, I guess, include face cards. So ace to 10, 1 to 10, but also jack, queen, and king, which is 11, 12. Is that right? 10, 11, 12, 13. Oh, and 14 is ace at the other end, of course. So which card are we on? Currently, we start at card 0. And we'll need a character to get the player's choice. And there's our main game loop going to be down here. We're going to keep on going as long as you haven't chosen to quit. And when you do choose to quit, we'll just stick a read key in to have a wee pause before the program closes down. Okay, so what's going to happen in the game loop? Well, this is it's going to be like an old game called what was it called again? Play your cards right. So what play your cards right is played like is that you start on 1 card and you work your way across 5 of them. So it tells us which card we're currently on, and then what value that card is. So we access the data in the current card variable. So current card it starts at 0, so we're looking at card 0. It's going to display card 0's value on the screen. And then ask the player, do you think the next card is going to be higher or lower? Now the way this game used to work is you didn't really have a choice to quit, but otherwise sometimes you're going to end up with a situation where the next card is the same, not higher or lower, and you can't win. So I'll put in a quit as a sort of way to draw the game there. We'll get an input from the keyboard to get the player's response. And we'll take the first character. So this is being treated as an array then. We've got a choice, which is a single character. And then we've got a string, which is effectively an array of characters. So if we access the first element of that array, that'll be if you type in H for higher, L for lower, or even if you type in the whole word, it's going to just pick the first letter of the word because that's the 0th element of it. So it takes the first letter of the input. Okay, and then we move on to the next card. So current card plus plus. Tell the player what the next card is. The current card has moved on to the next one. Tell them what the value of the next card is. And have we lost the game? So if you guessed that the next card would be higher and the current card is actually lower than or equal to the one before the current card, then you guessed wrong and you'll fail. So inform the player. And I'm going to fake having the player press the quit key on the keyboard. He hasn't, but it is time to quit, so that's one way to get there. The other way you can lose is if you guessed that the next card's going to be lower, but actually the current card in the cards deck has a value that is greater than or equal to the value of the one before the current card. And if that's the case, then same sort of idea, but instead it says that grammar. Instead it says that card is not lower, you lose. And finally, if the next card, one we haven't seen yet, would be greater than the length of the array. So for basically, let's say there's 5 cards, so card length is 5. If we're on card 4, 4 plus 1 would be greater than or equal to 5. So if our current card is 4, then this would come back true because we're at the end of the array. There's only 5 of them. It goes from 0 to 4. I'll step through this in a bit because it's kind of hard to visualize when I'm just talking about it. Okay, but if that happens, then you've pretty much won. Just write you have reached the end. Now this code is a little bit buggy, just something knocked together very quickly to demonstrate an idea. But end of the game, time to quit. I think we hopefully have something playable there. Let's run it and see. So we're on card number 1. As it so happens, we've been randomly dealt a value of 1, so it's pretty clear the next card is going to be higher. So next card is, this doesn't look right. If I made a mistake here, next card happens to be a 2. This is unlikely. This is, yeah, I've put in the wrong variable somewhere, haven't I? Oh, yeah, you're on card number. I'm not seeing what's wrong actually. You're on card number, current card plus 1. That card has the value. Surely that wasn't just a coincidence, was it? Oh, unbelievable, it was. Okay, right, that's just randomness for you, I guess, RNG being R. Okay, so card number 1 was a 2. I guessed the next card would be higher. It was a 12. I'm going to guess the next card's going to be lower. It was, it's a 4. Let's guess that the next card's going to be higher. It was 11. I'm doing well. I think this is the final one. I'm guessing that'll be lower. The card's a 3. I've reached the end. Well done. Let's see if I can lose the game. The first card was a 5. I'm guessing the next one's going to be lower because I'm trying. Oh, typical. Card number 2. Let's guess lower. Next card's an 8. It's not lower. You lose. Okay, so hopefully you get an idea of the gameplay. Let's step through it one line at a time then. So initialize the random number seed, create 5 cards, populate the 5 cards. So at the moment, our cards are all zeros. We choose a random number for card 0, a random number for card 1, 2, 3, and 4. Then it pops out the loop, start at card 0, and begin the game loop. You're on card number 0 plus 1. You're on card number 1, first card. That card has the value of the current card. So card 0 is 8. The card dealt was an 8 card. So ask the player if you're going to go higher or lower. Lower, I guess. So low L was the input there. I could have typed in lower, got the whole word in there, but either way, the first character of that is going to be L. Move on to the next card. So go from 0 to 1. What is the next card? Well, current card is now 1. What is the value of that card? It's going to be a 7. Let's not tab back. Yep, next card is a 7. Did we choose higher? Nope. Did we choose lower? Yes. So then also check whether the current card value, card 1, is greater than card 1 minus 0. 1 minus 0. Sorry, 1 minus 1, which is 0. So is card 1, which is 7, greater than card 0, which is 8? And it wasn't. So we guessed correctly. It carries on. Are we on the last card? We're on card 1. 1 plus 1 is 2. 2 is not greater than 5, so we're not on the last card. And we didn't choose quit, so it loops back around it. And it says you're on card number 2, it's a 7. Are you going to choose higher or lower? So that's the basic gameplay loop, and it's pretty much working. You can try that out on your own, maybe put in some more comments to explain what's going on, if any of it's confusing you. But there's definitely a few ways to refactor or rewrite this game. For example, you could use a while do loop instead of a do while loop. Could you use a for loop? You always could, yeah. For loops are very flexible. You could definitely use it, but I don't think it's the right choice for this kind of thing, because for loops, they're kind of intended for a fixed number of loops through something. Would it be possible to rearrange it so that current card only changes if you survive? There is a bug, which I didn't come across there, so it's not very common, but there is a bug where if you get to the last card and lose the game on the last card, this will trigger, or one of these two will trigger, but also this will trigger. So it will say you lose, but it also says you've reached the end. I mean, it's not wrong. We have lost by reaching the end, but we'd kind of like to make it exclusively one or the other. I guess we could put an else in there. But there's also other ways we could do it. We can add in more variables to manage that. There's also a better alternative to using the Q key to quit. But these are all things you could throw in. The basic idea of arrays and loops is there. It's all working. Okay, now there's still a couple more data types, which I'm going to mention to you. The first one's called an enum, or enumerated type for short. Let's say we've got an enum called weekday. So the weekday is going to actually be an integer. Enums, because they're enumerated, that's a number. That's the key. The key is that the enumerated word has the word number in it, kind of. So it's really an integer, where the word Monday is given the value of 0. The word Tuesday is given the value of 1. Wednesday is 2. Thursday is 3. And Friday is 4. That's kind of like the full version of how to initialize an enum. So what it's effectively saying is if you make something a weekday, it's really a number, but each number corresponds to a specific day, which is named. And it's not, I could use that for a variety of things. They could be, different character classes or, inventory types or whatever. But they are given values, and you can change those values if you like. You can make Friday day 5 if you want, but that would make too much sense in here. You can also leave the numbers out, and it will number them for you automatically. And a lot of the time, not quite all the time, but a lot of the time, we don't actually care what numbers are used, and so that is perfectly fine. And also, almost always, we want it to be integers. I think you can make it a byte or a long integer if you really have to. I can't imagine any enum ever needing a long integer, but it's possible. But really, you can shorten it to that. So just like the structure though, enums do not actually set aside any data. So if you want to use that, let me get rid of this, this game here. If you want to use that, you need to declare an object of that type. So weekday today. And when you assign it a value, you take it from the enum itself. Unfortunately, you can't just type in Monday. It's not going to let us do that. But if you type in weekday.monday, if you hover over it, that is given the value of 0. So essentially, that's an integer. There's an integer hidden away underneath, which we're basically saying int today equals 0. But we're allowed to put in Monday or January or human player or whatever in there, and it makes more sense, more readable. That's really the only benefit to using enums. They are actually no different from numbers, but they're more readable. Things you can do with them then, you can say today is whatever day it is. Today is Monday. So although it is a number, when you get it to convert to string, it does actually put that as a string, which is kind of handy sometimes. But in other ways, it can be treated as an integer. So how many days is it until Friday? So we'll take Friday, which would be 0, 1, 2, 3, 4, equivalent to 4, and we subtract today from it. So if today's Monday and that's 0, 4 minus 0, how many days is it away? 4, hopefully. Hopefully it'll say, hopefully it'll say 4 days until the weekend. Yep, oh, spacing, but it did do it. So sometimes it's treated as an integer. In fact, actually, it's always treated as an integer. It's just that sometimes it will convert that to a string for you like that, rather than putting a literal 0, 1, 2, 3, 4 in. You can also do algebra on it. You can add to today, make it the next day. And that looks a bit odd to write it that way. It's probably better to have a tomorrow variable, and tomorrow would be equal to today plus 1. But you can increment days, you can decrement days, you can add, subtract, multiply, whatever you need to do. It is just a number at the end of the day, no pun intended, but it lets you put in names for it instead. If you do need to literally treat it as an integer though, let's say you wanted a day 5 variable and try to assign weekday.friday to it, it's not going to let you do that, because although that is a number technically underneath the hood, it needs to convert that into an integer, because it's not currently an integer, it's a weekday. But you can always just cast it, and that does work just fine. A little warning there, it's not used, but that's no big deal. Okay, what other types do we have? Well, you can have a two-dimensional array. So let's say you've got a character array and you want to make it a map grid. Currently, we could just have in, let's use a hash symbol for a wall and a space symbol for an empty bit. But the trouble with that is it's literally one-dimensional. There's only one row. If you wanted to make it 2 rows, I suppose you could do something like that. and then just be careful, make sure you draw it on the screen in different x and y coordinates. But you can also make it a two-dimensional array, so you put a comment in there to let it know there's going to be one array in here and one array in there. Sorry, one index in there and one index in there, and the comma separates them. And the way to do that is then each row is an array of its own. So you encase that in curly brackets like an array. Don't forget the commas to separate them up. And that then lets you specify two indices, one for the x and one for the y. But because of the way it's structured, the first index tells us which line it's on, so that's actually going to be the y coordinate first. So if you do it this way, it'll be y comma x. So be careful of that. You can also make it a three-dimensional array, 4 dimensions, 4, 5, whatever. But it starts to get a bit hard to follow. And a bit later on, we'll be seeing how to use that in an actual game. So I'll come back to that later. But another type you should be aware of is a jagged array. For example, that's it there. A jagged array is an array of arrays. Now, a two-dimensional array is literally two-dimensional. It is a grid or a matrix form, so everything has to have the same width and height. But what about planets and moons? Every planet has a different number of moons, so it wouldn't be a matrix. Or if it was, you'd be wasting a lot of space on planets that don't have as many moons. So the way that works is, oops, each array is now completely separate. It's literally an array within an array rather than being linked to each other. So the first array has just got one thing in it. Maybe the next one also has just one in it. But then other ones could have two objects, two items. And you couldn't do that in a two-dimensional array because it wouldn't be filling the second dimension in these ones. Just one more. You could have Mars with its 2 moons. And that's a jagged array because this is one element. Let's line them up. That's 2 elements. That one's 3 elements. So they jut in and out, and the next one, in fact, let's put that one down here. So it's jagged because it goes in and out, back in, and the length of the array is kind of jagged. So hopefully you can see that that does have occasional uses. And the last one I'm going to mention then is a class called a list. There's plenty of other data types out there, but one that's not really technically built into the C# language as such, but added on in a library is the list. Now, let's say we're making a 3D object. So a 3D object is made up of vertexes or vertices. So if we take the positions of each vertex, we can list them as a bunch of floating point numbers. Now this introduces a new sort of syntax that I don't think you've seen before. It's called a generic. More on that another time, but basically it's saying what we're going to make a list of. So we're going to make a list of floating point numbers. This is the constructor for it. Make a new list of floating point numbers, and because it's a constructor, it does need brackets, but they're empty. So now we've got a whole bunch of vertex positions. How many? Well, currently none. It's empty. But you can do something like count them. Now this is equivalent to the length of the array. The count of objects in a list tells you how many there are. So let's step through. Create a list of vertex positions. There's currently 0 of them, so there's nothing there. Get the count of vertexes, 0. But you can add stuff in it. So we could say vertex positions dot add. We could add a whole range actually. We could add an array. Wow, that's pretty dense there. It's creating an array with 3 things in it, and then adding that array in as a range of vertexes into it. Or you could add one individual thing at a time. Vertex positions dot add put a floating point number in, that's going to add that. You can insert them. And if you do that, you need to say which position to insert them. So after position number 2, we're going to insert number 15. You can insert a range as well. So after position number 3, we're going to insert a whole array of floating point numbers. I'll just stick a couple in. Let's step through that. Make a new list. Currently there's nothing in it. Add a range, and then there's 3 in it, 3 floating point numbers. We just told it to add 3, 3, and 0. They're now in here. Add the number 20 onto the end, 3, 3, 0, and then a 20. Insert the number 15 after element number 2. So we've got 3, 3, 0, 20. After doing that, we've got 3, 3, 15, 0, 20. So it stuck it in the middle instead of on the end. And as you can probably guess, after position 3, we're going to insert these 2 numbers. So currently 3, 3, 15, 0, 20. Then it becomes 3, 3, 15, 20, 10, 0, 20. So that's different ways you can add stuff to a list. And you see it behaves very much like an array. And that's because there is an array inside the list. So you are actually accessing an array. There is literally an array in there. So the trouble with arrays is you cannot change the size of them. And list gets around that by what it does is, unbeknownst to you, once it runs out of space in the array, it creates a whole new array, copies everything into it, and then gets rid of the old one, which is a bit of a hassle for you to do manually. So it's quite handy to have a list that will handle that for you. You can then add stuff and remove stuff whenever you need to. Oh, yeah, so how do we remove stuff? Well, there's different ways. You can say remove the number 3 from it, and it'll take out the first value that has the item value 3 from the array inside the list. Or you could say remove at. Now the difference, I put 3 in there both times, but the difference is this is going to look for the number 3 in the values, and this is going to take out whatever the value is at position 3 in the list. Don't get them confused. Or you can do something a bit more complex. You can use a lambda expression, which means remove, it kind of looks like this, remove everything called x, where, think of that little symbol as meaning where x is equal to 20. So it's going to look through and find everything where x is equal to 20 and remove all of those. Oops, sorry, remove all of those. Demonstrate that quickly. So we'll add everything first of all. Okay, so we've got 3, 3, 15, 20, 10, 0, 20. Remove the value 3 from it. There's 2 of those. Let's see which one it removes. Only one of them. I think it was the very first one. So everything has been pulled forward 1 step to fill up that gap. Now we're going to remove the thing at position number 3. So that should be the number 10 is going to disappear. It did. And then remove everything called x where x happens to be 20. So it's going to take out all the 20s, hopefully. It did. And how many is there left? There's 3 of them left. Okay, so that's lists in a nutshell. We'll not bother you with them too much right now, but they will definitely come back to that. Very useful for actual gameplay. So I think I'm going to leave it there for now.